Hello, we're going to continue with question 3, which is some PDF practice. Okay, so with PDF problems, our first step is always going to be that we find the PDF that we're going to be using. And the way we do this is we look at the problem, we read it, and we break it down. We break down what the problem is asking for into its component parts so that we understand exactly what it's asking for, and then we can understand exactly what distribution would probably apply to this scenario, and then we use that distribution to solve the problem. So we're going to start on that. The question asks, the average student waits until the last 2 days to start studying for an exam. What is the probability that a student starts studying before 3 days? So we're given 2 here, which is our E of x. And we're given units that are in days, which means our units are time-based. Now, if you're given units that are in time, that's a big hint because that means the distribution has to be a continuous one. We don't use discrete distributions in units of time. So now we also see that the probability that a student starts studying before 3 days is what we're going for. And it seems to me like this sort of, if you imagine this as a graph, let's say, I think the graph would probably look, 2 is right here, this would be the average, so it's probably going to get exponentially less likely over time. And there might be some, like it might curve like that, it might go like that. I'm not quite sure. But in general, this is a pretty clear indicator to me that we're going to be using an exponential distribution here. If you have events that are, if you have a question that's of this format, it's usually asking for an exponential distribution. All right, so now that we've identified we're using the exponential PDF, let's write that out. Now, we always write our PDF functions out as f of x. F of x is an indication that this is a PDF. And the equation for the exponential PDF is theta e to the negative theta x. One big note is that you're going to have to memorize all these PDF functions for all the different PDFs. They're outlined mostly on lecture 9. But you will have to memorize them, and that is going to be one of the major components of your studying. All right, so once you memorize the PDF and you know what it is, the exponential is pretty easy because it's just theta e to the negative theta x. How does this help us solve the problem, you might ask? Well, we need to find what theta is. And we can do that because we know what E of x is. E of x is 2. We're given that. But you might remember another equation we went over in class, which is that E of x for a continuous distribution is the integral of x f of x dx. Right? So you can do this integration. You could solve this integration x e to the negative theta x. You could solve that, but that would require integration by parts, and I don't really want to do that in this video. So you can also memorize this next tidbit of information, which is that the expected value of x for an exponential distribution is 1 over theta. Right? So we can just apply that. We know that 2 equals 1 over theta. So theta equals 1/2. All right. So now that we know that theta equals 1/2, what are we going to do with that? Well, we're asked, what is the probability that a student starts studying before 3 days? So this is not asking for a specific point in time, the probability of that happening. If we were asked for the probability that a student starts studying at 3 days, we would use the PDF. But we're asked for a range of time. So that's an indicator that we need to use the CDF. Now, the CDF we always write as f of x, and the CDF is always equivalent to an integral from 0 to x of the PDF times dx, which, if you see our notation up above, this is x0 f of x dx. All right, so now let's put that back up here, and let's just fill in the blanks, and let's get ready to solve. So 0. We need to figure out what x is in this scenario. So if we're asked to find the probability that a student starts studying before 3 days, well, the CDF always starts at 0. So what we could do is we could find the CDF from 0 to 3 and subtract that from 1, because the total probability will always be 1, and that will give us the probability that a student starts studying before 3 days. So let's find the CDF where x equals 3. So now we just plug in our PDF function, but theta is 1/2, so 1/2 e to the negative 1/2 times 3. Although actually, wait, here you don't plug in x yet. Okay, now we need to solve this integral. So I believe you can just integrate this with the chain rule. This is negative 1 over 1/2 times 1/2 e to negative 1/2 x. And then these cancel out. And we do 0 to 3. So we're given e to the negative 1/2 I forgot to include a thing here. There's an x here that I forgot to add. So that's why this 1/2 is here. Doesn't actually change anything. Okay. Yeah. I'm just checking my math. Okay. So this is x 0 to 3, which is equivalent to e to the 0 minus e to the negative 3 over 2. And that, our answer is going to be 1 minus e negative 3 over 2. You don't have to simplify this. If you ever given math on the exam where you would probably need a calculator to go any further, that's where you should stop. All right. So this is how you do the PDF for a continuous PDF. This is how you do it. The most important parts are the first part, you find the PDF that you're going to use, then you write out the function, which we do, let me make this more clear. First find the PDF, then we write out the function, then we define whatever missing variable we have to define. So in this case, we found theta here. After that, we realized that we needed to use the CDF to get our actual answer. So we used the CDF here, and we solved for our final answer here. All right, good luck on your studying.